Welcome students, Standard 12th, Chapter 7, Java Basics. Chapter 6 we studied about the concept about object-oriented programming, and now in Chapter 7, 8, 9 onwards we will be applying those concepts in real programming of Java. Remember, Chapter 7 is very lengthy, but it covers all the basics of Java language and it is very easy to understand. It is lengthy because it covers almost all the basics of Java language. So let us begin with Chapter 7. Introduction to Java. Java, as you know, is an object-oriented programming language, and it is developed by Sun Microsystem in 1991. Sun Microsystem is the company which is best known for its high-end Unix workstations. It is one of the very popular company in developing software. Remember, because this textbook is written before 8-9 years, so it says that it is developed by Sun Microsystem and it is called Sun Java. But at present, Java has been taken over by Oracle company, so now it is actually called Oracle Java. But right now, because we are following textbook for board exam, so we say that Java is developed by Sun Microsystem, a company who has developed high-end Unix workstations. It is modeled after C++. So gradually, if you see, there was Pascal language, then from Pascal language came C language, then from C came C++ language, and then from C++ they derived Java language. So the Java language was designed. What was the reason why it was designed or why it was created, Java language? So it was designed to be small, simple, and most important, portable across platforms and operating system. It should be a small language, it should be simple, easy to understand language, but above all, Java designed for keeping one main purpose in mind, and that is its portability, both at the source and at the binary level. Remember, at source level, every language is portable. So if you write source code of any programming language, which you write in Notepad suppose, then it is portable on any machine, any language, any operating system. But Java is not only portable at source level, but it is also portable at binary level. Java is small, fast, efficient, and easily portable to a wide range of hardware devices. Java is considered as the most ideal language for distributing executable programs via World Wide Web. Why it is considered as the most ideal language for WWW? Because when we talk about World Wide Web, it comes across many different machines and many different operating systems. So Java has capability to run on all these different machines and on all these different operating system and different platform. And that is why Java is considered as the most ideal language for distributing executable programs via World Wide Web. Java is also a general purpose programming language. So it is a general purpose programming language. It is not hypertext markup language like HTML. It is like C, Pascal, Fortran. It is general purpose programming language for developing programs that are easily usable and portable. Again, the word portable is very important across different platforms. Java includes a set of class libraries that provides basic data types, system input and output capabilities, and other utility functions. So it has a set of class libraries and that class library provides all the data types, output and input capability functions, and other utility functions. So that comes ready-made with Java. These classes are part of JDK, that is Java Development Kit. So when we install Java, we install JDK, that is Java Development Kit, and that kit contains all these things. There are other things also that Java Development Kit contains, and that is it has classes to support networking, common internet protocols, and user interface toolkit functions. All these are used for the advanced programming while using Java language. So, but remember that JDK, the full form is Java Development Kit, and that kit includes so many ready-made class libraries, data types, system input and output capability, other utility functions, different classes to support networking, common internet protocols, and some user interface toolkit functions. Java is platform independent at both the source and the binary level. Now let us understand what is that. Platform independence is a program's capability of being moved easily from one system to another. So remember, the language before Java, that is C, C++, they were not platform independent. Platform independence, matlab, if I write a program in C language in my computer, if I compile that program, and that compiled program, that is that binary conversion of that program, cannot be taken on other machine. It will not run there, because when I compile C program in my computer, it gets compiled for a machine on which I am compiling it according to the infrastructure or the memory and the hardware of my computer, which will be different from the rest of the computers. So it will not work on other computer. But Java is platform independent at both source as well as binary level. At source level, Java's primitive data types have consistent sizes across all the development platforms. So that is data types which we will learn in detail in further in this chapter itself. But the Java's primitive data types has same size, same meaning, same usage across all the development platforms. And at binary level, platform independency is possible due to bytecode interpreter. So there is a bytecode interpreter which makes your program platform independent. Let us see how it is making it platform independent. So the designer of Java, they choose to use a combination of compilation and interpretation. They use both the things, compilation as well as interpretation. Now, before we see that this new slide, you need to understand the difference between compilation and interpretation. Compilation means it takes the whole program together and then translates into binary language, and it creates a bytecode or a binary code. Whereas interpretation means it will interpret one line of your program and then it converts that code into machine understandable form on whichever machine you are interpreting. It does not create any bytecode for future use. It just interprets each and every line individually. Next time if you interpret, again it will start from first line and it will interpret everything. Whereas compiler, once it is compiled successfully, you don't need to compile it again. Then you can use that bytecode which has been created by compiler as many times you want. So the program written in Java are compiled into machine language for a computer that does not really exist. Here is the big difference between previous languages and Java. Previous languages, they were compiling the program for the machine on which we are compiling it. Whereas Java compiler is compiling the Java program, but it is not compiling for the machine on which you are compiling. Rather, it is compiling it for a virtual machine, and that is called JVM, Java Virtual Machine. So if I compile a Java program in my computer, it is not getting compiled according to or depending on the architecture of my computer. Rather, it is getting compiled for a machine which is not actually existing anywhere, and that virtual machine, which is called Java Virtual Machine. Now this machine code, that is the bytecode for the Java Virtual Machine, is called Java bytecode or binary file or the class file or the machine language file. So that is how Java first step is done. As you see in the picture, there is Java source program written which we will compile, then it will get converted into Java bytecode, and this bytecode then can be taken on different machines. Machine on which Linux is working, machine on which Mac operating system is working, machine on which Windows operating system is working. all these machines, they will have their own interpreter to understand this bytecode. So platform independency is gained. So this bytecode can be taken on different machine, and then different machine will have their own interpreter to understand that. So it is something like I have a video talk in English language, and then there are subtitles, different subtitles, or you have a video file downloaded where there are 3 audio channels. If you want to watch that video in Tamil, you select the channel accordingly. If you want to watch that video in Hindi, you select the audio channel of Hindi, and so on. So that is how Java programs are made platform independent. Java programs are compiled for Java Virtual Machine, that is JVM, and it generates Java bytecode. This Java bytecode is machine independent. It is not for one particular machine, but it is machine independent. To execute this bytecode, different machine requires different Java bytecode interpreter, as we have seen in that previous picture. The only disadvantages of bytecode is its slow execution speed. Remember, interpreters are slow to get executed rather than compiled. So the only disadvantage is that interpretation process is slow, but that slow means it is in some microseconds. But still it is comparatively slow. So, but the benefit of that what we are getting is its platform independency. We may convert that bytecode into native code if you wish. Native code means on which machine it is running, but then it will become fast. It will get executed fast, but then it will become machine dependent. So the only disadvantage of bytecode is its slow execution speed. But there are tools available to convert this Java bytecode into native code. As I said, it is possible to convert this Java bytecode into native code. Suppose I got one bytecode in my machine, and then there are tools using which I can convert that bytecode into my machine style of code, that is native code. But then the limitation of that code would be it will not remain machine independent. So native codes are faster to execute, but then it does not remain machine independent. So that is how Java programs are getting compiled and remains machine independent for every different machine. A Java program, now what Java program is made up of? So a Java program is composed of classes. Now what are classes and details about classes we will again learn further in chapter. But right now you understand that every Java program is composed of different classes. There may be one or there may be n number of classes in your Java program. Java program should have at least one class, and then it must have main method in it. So as I said, a Java program is composed of either one or as many classes you want. There is no limit how many classes you can have in your Java program. It depends on your requirement. But it has to be one class minimum, and that one class should have, rather must have main method in it. So if your Java program is made up of one class or 100 class, but there has to be one class where there is main method written in it. The extension of Java source file, when we type Java file in Notepad or any IDE, then the file extension should be .java. The compiler, to compile Java program now, how to compile Java program? So to compile Java program, we need to give the command javac followed by the name of the program. For example, javac followed by file name. If file name is calculation.java, then it should be like that. Now when you compile, there are chances that program may not compile successfully. But if it compiles successfully, then it will generate a file with .class extension, which is the bytecode file. So as we have seen in this Java source file, we compile, it will create Java bytecode with .class extension. If there is error, it will point out those errors, and then we remove those errors and again we compile. But once it is successfully compiled, it will generate a .class file which is called bytecode file or binary file. In JDK, that is Java Development Kit, type Java file name, Java followed by file name to execute the file. So to compile file, you write Java C followed by file name, and to run or to execute the file, you write Java followed by file name. To execute Java program, we only need .class file, that is bytecode file. We then don't need source file. So here, where it says Java file name to execute the file, this file name is bytecode file name. It is the bytecode file name, and here Java C file name is the .java file name, that is the source file name. So that is how we compile file and then we run or execute the Java file. As you see this program, simple program, it shows program. I have divided into two screens. So if you look at the program, those first few lines, 4 lines rather, they are comment line, which begins with /$ and ends with */ lines with beginning with /* and ending with */ and lines beginning with // all these are comment line. We will discuss about this also further in this chapter. Then actual program starts here where it says public class callCost. So we are creating a public class and the name of the class is callCost. And that class contains one method which is a compulsory method that says public static void main string square bracket. Remember, this is not a rectangle, it is open and close square bracket and then args. And then we open curly bracket for main method and we declare some variables. Remember, none of these things we have studied till now. We just go through this program and then we will study about all these things. Double balance, double rate, double duration, double cost. So all these are the variable name and their type is double. So balance, rate, duration and cost. Then starts computation on page 2. We take value of balance as 170, rate, call rate is 1 rupees 0.02 or 1.02, duration is 37 seconds, and now we calculate the cost of the call. So call cost would be duration into rate, and then balance would be old balance minus cost. So that will update the balance. And now we will print everything, displaying the result. Again, this is a comment line. These 2 are also comment line. These 4 are also comment line. Computation here, that is also comment line. So remember, it is not much important, but we will discuss what is comment. Then system.out.print call duration within inverted comma. System.out.print duration without inverted comma. So call duration is written within inverted comma, so it will be printed as it is on screen. CALL space DURATION colon and blank space. But second line, that is system.out.print duration, which is duration is written without inverted comma, then program will look for the value stored in duration. So value stored in duration is 37. As you see here, duration is 37. So it will print call duration colon 37. It will print value of this variable. Then again system.out.println seconds. So finally this three line will print one sentence saying that call duration 37 seconds. And then on next line it will print system.out.println balance. Again it is written within inverted comma, so this will be printed as it is, plus balance without inverted comma, it will print the value of this latest balance, that is 170 minus whatever cost and rupees. So final second line will be printed as balance some value rupees. Difference between print and println. Here you see print print, and then println, println. The only difference is println will add a line break. So wherever there is println, it will print these seconds, and then after seconds it will have enter key pressed. So as you understand, first line would be call duration 37 seconds and then enter, cursor comes on next line, and on next line it prints balance XYZ rupees, and then again cursor comes on next line, and then program gets over. This is very basic program. There are so many things which we have not studied, but because the first program given in chapter 7 for you is this, so we discussed it. Let us move further. So what are the program basics? Now let us understand. So the text written after double slash and between slash star and star slash are comments. As I said, they are comments. Variables are declared using data type followed by variable name. So these are the variables: balance, rate, duration, cost. Their variables are written as data type, that is double, followed by variable name, like integer a, float b, character n, etc. But again we will discuss what is all this. Computation part contains expressions using assignment statement. So computation part contains assignment and calculation and expression using assignment statement or assignment operator equal sign. So you see all these are equal sign. That is assignment statement. Method system.out.println adds a line break after the end of the information. And note the use of plus operator. As you see here, plus operator, plus, plus, plus operator. It is called concatenate operator. Concatenate, to concatenate means to join. And it is used to combine two different types of information. So here balance, this first balance, this is a string. This balance is a variable. Again, this rupees is a string. So to combine this, we need to use concatenate operator, that is plus sign. So these are something about the program which we have seen. Still it will continue. There is something called Cite text editor. Now Cite editor is for Linux users. Those who are using Linux operating system, they have this operator, this editor available with Linux. As we have Notepad, Linux has got many different operators. There are many editors. Linux has got so many editors. We have only Notepad and WordPad. These are the two editors. But Linux has got so many editors. Cite is one of them. Cite is a Scintilla based text editor. It is a text editor which is lightweight and it is built for speed and performance. This full form you don't need to remember. Scintilla based text editor, you don't need to remember this full form because it is not given in the textbook. Cite is a powerful text editor. It is used to write, compile and even run programs of different languages. It is designed for source editing. Source editing means you've written source code of program and you can even edit it and perform syntax highlighting facility. The second line is very important to understand. Syntax highlight facility is something where color of the text will automatically change. Like wherever there are some data type coming, color will be different. Wherever there is a string coming within double inverted comma, color would be different. So that is called syntax highlighting facility, where editor automatically changes the color of different things. So that is called syntax highlighting facility. Some useful Cite commands which you need to remember for exam point of view are file new to open a new file in Cite, file save to save file in Cite, tools compile to compile programs written in Cite, and tools go to execute program written in Cite. So remember these 4 commands. It is given in textbook 3-4 times in different chapters. So file new, file save, tools compile and tools go. Structure of a Java program. Now the next is, what is the structure of Java program? Now you know that programming language differ from human language in being unambiguous and very strict about what is and what is not allowed. Understand this statement clearly. Programming language differ from human language in being unambiguous. So human language, you know that sometimes we use ambiguous words, or sometimes what we say, it has got different meanings at different point of time, or sometimes we want to say something different but we use different words. But in programming language it is not allowed. It is very strict about what is and what is not allowed. So whatever is allowed, we have to follow that, and whatever is not allowed, we cannot use it in our programming language. Let me give you one simple example here. You know that this system.out.print. Now in spoken language, instead of print, if I say display, it is fine. Keeps almost the same meaning. But here we cannot change system.out.print to system.out.display or system.out.show. We cannot use synonyms because these are the words which are defined in Java language and they have some specific meaning which we cannot change. And that is why it says that every programming languages are very strict about what is and what is not allowed. The rules that determine what is allowed in a language is called syntax of the language. So syntax of the language means the rules that will determine that what is allowed in this language, that is called syntax. Syntax rules specifies the basic vocabulary of the language and how programs can be constructed using variables, expressions, statements, branches, loops, and methods. We will study all these things in this chapter itself, but that is what the basic vocabulary of a language. So as you know that if you try to study Tamil language, so what you need to study about that language? Two main things: vocabulary, that is the different words of that language, and then syntax, sentence formation of that language. Similarly, for learning any programming language, you need to study about the reserved word or the special words of that language that constructs variable, expressions, statements, branches, loops, methods, all these things, and then how all these things can be written in your program, the syntax of that. So that is what the syntax rule specifies. A syntactically correct program is one that can be successfully compiled or interpreted. So if there is no syntax error, then program will compile successfully as this program is syntactically correct. But suppose here system.out.print, if I write system.out.show, it will generate error. If I remove this inverted comma after call duration, I start here inverted comma, but I don't put the closing inverted comma, it is syntax error. So that is what, if there is no syntax error, then program will be successfully compiled or interpreted. As Java is an object-oriented programming language, everything in Java is defined as part of a class. Thus, a method can't exist by itself and it has to be part of a class. So like in Java, you can't write directly a method, which you can write in C language. In C language, you can write methods directly. But in Java, you cannot write variables and methods directly. It has to be part of a class. There has to be a class, and then in that class only we can write variables and methods. They become the part of class. The definition of a method, which is also called function in Java, consists of function header, that is the name of the function, and the sequence of statements enclosed between curly braces. So you write function name and then it followed by open and closing curly bracket. Again, as you see here, this function name followed by open curly bracket which gets closed here, curly bracket is closing here, end of main, and this is end of class called cost. So that is how it is followed by open and closing curly bracket. Each Java program must have one class. We are repeating this thing once again because this is very important to understand. Each Java program must have one class that contains public method main. A Java program can contain other methods also besides main, but there has to be one method with the name main, and as well as there can be other variables also. So there can be as many variables you want and as many methods you want in your program you can write, but there has to be one class where there is main method defined. Variable declaration before and after main is optional. So before main method or after main method, it is totally depending on the type of program you are writing and the requirement of the program, that where and how many variables you need. You may need it to be declared before main, you may need to declare it after main method. It is totally optional. Wherever you need, you can declare variables, but it has to be part of class. You cannot declare variable outside class. You cannot declare any method also outside class. Java is a free format language. So there is no fixed format of Java language that you write like this. It's a free format language. The layout, like blank spaces and indentation, are not part of Java syntax or semantics of the language. So what you see here again, all this layout, this is not part of Java syntax. You may write the entire Java program in one line, but then it is not good or it is very difficult to read that program. So remember, it's a free format language. All the blank spaces and indentation are not required. It is only to increase readability. Java compiler does not care about program layout, that how you have typed your program. Java compiler does not care about it. In simple, we can write the entire Java program on a single line. We may write the program which you see here. This entire program could have been written on one single line. But then you know that how it is difficult to read and to understand and to explain that program. And above it, when there is some error occurring in that program, it is very difficult to locate that error and to correct that error. So even though these blank spaces and indentation are not compulsory or it is required, it is not required, but still it is a good practice to write program like this. But otherwise it is a free format language. Program layout is only important for human readers. So remember, it's a free format language. There is no fixed structure. Only thing is that it is made up of classes. Now next lecture we will discuss about Java data types. Till then, take care and go through all this thing. The basics of Java is very interesting and very important for you to understand. Remember, the program which you see here is again almost like not proper program, but because so many things we have not studied. So this textbook has given very simple program for calculating call cost. And then you remember the difference between print and println, use of plus operator, that is concatenate operator, what is cited text editor, 4 different commands of cite editor, and then what is the syntax and rules and the vocabulary of any programming language, the difference between compilation and interpretation. Remember once again, compiler or compilation process reads entire program and gives list of errors if any, whereas interpreter interprets one line and gives only one error where the first error comes. Compiler, if it is successfully compiled, it will create a class file or binary file or bytecode file, whereas interpreter is not creating any bytecode file or binary file or class file. So next time if you want to run, you need to interpret it again even though there is no error, whereas once it is compiled successfully, you don't need to compile it again and again unless and until you make some changes in the program. Now we will discuss about Java data types. First you need to understand what are data types. So data types determines, or they are used to determine required memory size, how much memory it will occupy, types of values, which kind of values can be stored in that data type, range of values, what range of values can be stored, and type of operations that can be performed on that variable. So whenever we declare any variable, we don't just write name of variable, but we write data types also before that variable name. As in the sample program you would have seen here, all these variables, 4 variables, they are written as double balance, double rate, double duration, double cost. So that is, double is a data type, but because here we used only double because we have not studied data types at this point of time, but now we will discuss in detail. So that data type decides that whenever we create any variable, then that variable, how much memory it will occupy, what type of value we can store in that variable, what range of value we can store, and then what kind of operations that can be performed on that variable. So Java supports 8 primitive data types that handle common types for integers, floating point numbers, characters, and Boolean values. These 8 primitive data types are byte, short, integer, long, float, double, char, which is pronounced as character, and Boolean. So these are the 8 primitive data types of Java language. So you can, to again simply understand data types, it's like a different size and different types of bag. We have different types of bag, like from small plastic bag, or what we call is jablu, to American Tourister, a big bag. So that different bags, and we know that different bag has different usage. Some, if I want to get something which is wet, the product which I'm getting from outside, if it is wet, you know that we don't take uh, cotton or clothing bag, but we take plastic bag. Whenever we want to go for some shopping for few things, we take small bag. We don't take American Tourister with us. As same way, when we are going for some tours and travels for 8 or 10 days, we don't take plastic jabla, or rather plastic small bags, but we take American Tourister or some suitcase. So we know the usage of different bags, and we know that what are the sizes of that bag, what can be stored in that bag, and what we can again perform on that bag. We can throw that bag, you know that big American Tourister, when we go through flight, then in flight where they might be keeping our bag, they might be throwing it. So we know that which bags can be used, where if it is being thrown from one place to another place while shifting or transiting, it is okay. So all these things are data types you can compare with different size and type of bags. Now let us see the actual data types and what they are used for. Byte, short, int, it is again pronounced as integer, and long can hold only integers, that is only whole numbers, numbers without decimal point. For example, -3, 345, -9893447, and like this. All these are valid, but 0.23, 100.0, etc. are invalid, because byte, short, integer, and long, all these 4 data types can hold integer whole numbers but cannot hold decimal point. Whereas float and double can hold any number, number with or number without decimal point. CHR, that is character. Character data type can hold a single character. It can hold only one single character from Unicode character set, and it is written within single inverted comma. So for example, A written within single inverted comma, 4 written within single inverted comma, hash symbol written within single inverted comma, and etc. But remember, it must be written within single inverted comma, and then there should be only one thing within single inverted comma. Boolean data type can hold any one of the two values. either true or false. You cannot store anything other than TRUE true in small letter and FALSE false again in small letter, exactly like this, nothing else. So Boolean can store either true or false. So these are the 8 primitive data types. Once again, byte, short, integer and long can store any number but number without decimal point. Float and double can hold any number with or without decimal point. Character can hold any single character within single inverted comma, and Boolean can hold either true or false. So this is the table given in textbook to understand the data types. On left hand side, the first column is data type, then how much memory it occupies, what kind of value it can store, range of values, and its default value. So byte occupies 1 byte of memory, short occupies 2 bytes of memory, integer occupies 4 bytes of memory, long occupies 8 bytes of memory, float again occupies 4 bytes of memory, double occupies 8 bytes of memory, character occupies 2 bytes of memory, and Boolean occupies again 1 byte of memory. What kind of value it can store? So first 4, that is byte, short, integer and long, can store integer number, whole number. Whereas float and double can store real numbers, number with or without decimal point. Character can store character and Boolean can store Boolean value true or false. Range of values. Byte, when you use data type as byte, the range is -128 to +127. That means if you want to store number 700, you cannot use byte data type because its range is small. It's a small plastic bag where you cannot keep so many things. So byte is smaller size, range is small, short data type range is bigger, integer data type range is even bigger, and long has got biggest range for integer data type. Similarly, float can store any number with 10 raised to plus or minus 38. So with about 7 significant digits. And double can store any number multiplied by 10 raised to plus or minus 308 with about 15 significant digits. But all these has, that is byte, short, integer, long, float and double, their default value is 0. So if you don't give any value, by default it is 0. Character uses 16-bit Unicode character, and because it uses 16-bit Unicode character, it is possible to store many different, more than 65,000 different characters using character data type. But again, internally it is stored as number, so its default value is 0. Boolean, you need to remember, for exam point of view, the default value for Boolean data type is false. So if you create any data type as Boolean, any variable as data type as Boolean, the default value is false. Remember that? These data types are called primitive as they are built into the system. They come with Java. So they are built in the system, so they are called primitive data type. They are also machine independent. So even the data types, because many languages data types are not machine independent. They have slight difference from different machine. But for Java, all these primitive data types are again machine independent, and their size and characteristics are consistent across all Java programs on all different kinds of machines. Integers, now this is again interesting to understand. Integers with b bits, number of bits. So here, as you know, byte occupies 1 byte of memory, that means 8 bits. You know that 1 byte is equal to 8 bits. So integers or numbers with b bits precision store signed values in the range of -2 raised to b minus 1 to +2 raised to b minus 1 whole minus 1. Remember, this formula is given, there is some typing mistake in textbook. This is the correct formula, where b is for number of bits. So if you take example of byte, there are 8 bits. So the range is, how this range is calculated? This range minus 128 to plus 127. How this range is calculated? How this range is calculated? So it is using this formula. So minus 2 raised to 8 minus 1. Because 1 byte, it occupies 1 byte, that is 8 bits. So minus 2 raised to 8 minus 1, that is 7. So 2 raised to 7 is 128. 2 plus 2 raised to b minus 1 whole minus 1. So that is 2 raised to b minus 1 is 128. Minus 1 is 127. And that is why the range of byte is minus 128 to plus 127. And you can calculate all these ranges using this formula. But you don't need to remember. You remember this formula, but you don't need to remember the range. When they are preceded with the word unsigned, suppose you write unsigned byte. If any data type, any variable you are creating with data type as byte, the range is minus 2 raised to b minus 1 to plus 2 raised to b minus 1 whole minus 1. But if it is preceded with the word unsigned, means there is no sign required, means there is no negative numbers, then the range is 0 to 2 raised to b whole minus 1. That is 0 to 255. 2 raised to b is 2 raised to 8. 2 raised to 8 is 256. Minus 1 is 255. So 0 to 255. But it is only when you are sure that in this variable no negative number will come, then you can say unsigned. Unsigned byte, unsigned short, unsigned integer, unsigned long. Then the range will change. Then there is no negative numbers coming because it is unsigned number, so no negative numbers will come. Real numbers in Java are compliant with IEEE 754. IEEE, you check for the full form, it is the institution where they create, standardize everything related to science. Science related all the terminologies and their rules and regulations and their how it should be used, that all these things are decided by IEEE. So IEEE 754 rule is compliance with all the real numbers in Java. The character type is 16-bit precision and it is unsigned. You know that character there should not be negative sign. So it is a 16-bit precision and without any sign. It is unsigned. What is variable now? If we want anything to be remembered by the computer during program execution, then it needs to be stored in the computer's memory. See, for example, the program which we had seen, let me take you back to that program. That this program, if you see, while calculating balance and cost, we need few values to be remembered, like balance, old balance, rate of call, duration of call. All these things should be remembered by the program. And because of that, we created these 4 variables. So remember, that is what it says, that whenever we want our program to remember something during program execution, then it needs to be stored in the memory of the computer. Programs can manipulate the data stored in memory. So the value which is stored in the memory can be manipulated. As you know that we calculated balance and we changed the value of balance afterward by subtracting the call cost. Using machine language, data can only be referred to by giving the numerical address. Remember, that was the tough time when there were no higher level language and there was only machine language. Now in machine language, whenever you want to store some value or some value you want your program to remember, you need to remember the even numerical address of your memory. Okay, which part of memory that value you are storing. So that memory address would be hexadecimal code, very complex number. But you need to remember if you are using machine language, so that it gives you the location in the memory where that value is stored. But in higher level language, that is like C, Fortran, Pascal, COBOL, all this Python, Java, all these languages are high level language. So in higher level language such as Java, user defined names are used instead of numerical address. And the programmer needs to remember only the name of the variable or that user defined names. So just remember how it is easy to remember all these variable name and their purpose: balance, rate, duration, cost. Very easy. But remember, suppose you are doing machine language programming, then you would have done, instead of writing balance, there would be some hexadecimal code like A123BC, something like this. Any hexadecimal code, very complex code, which would be very difficult, that what it is actually meant for, if it is meant for balance or rate or what. So that is what it is. Something like if we recognize everybody with their Aadhaar number, how difficult it becomes. If you don't know the name of anybody and you need to recognize everybody with their Aadhaar number, it becomes very difficult. We can even, sometimes we cannot recognize our own family members, if, or we cannot call them by their name if they don't have name, and just we need to remember their Aadhaar number only, then it becomes difficult. Similarly, in machine language, it was very difficult to store values in memory because we need to remember their numerical addresses. But in higher level language, we just need to remember the name, variable name. So a name used to refer to the data which is stored in memory is called variable. One or more variables can be declared in Java using declaration statement with following syntax. So this is the syntax where you write the data type, that is type name, and you write variable name. Type name is used to specify the data type like integer, float, double, whatever, etc. And variable name is used to denote the list of variables separated by comma and ending with semicolon. So a variable can take different values at different point of time during the program execution, but refers to the same memory location. So once you create a variable, it may take different values in your program. For example, balance is 170 here, but after that, after this statement is get executed, the value of balance will not be 170, it will change. So a variable can take different values at different point of time in your program, but one variable will refer to the same memory location. A variable can be used in Java program only if it is declared. So if you declared that variable using this declaration syntax, then only you can use it in your program. If you have not declared any variable, you cannot use any variable directly. So before using variable in Java program, you must declare that variable. When computer executes a variable declaration statement, it sets aside memory for the variable and associates the variable's name with that memory. So whenever we create any variable, or rather when we declare a variable in Java program, what computer will do is it will reserve a memory space depending on the data type of variable. If I create a variable with the data type short, then computer will reserve 1 byte of memory which is associated with that variable name. If I create a variable with data type as double, then computer will reserve 8 bytes of memory and it will associate that 8 bytes of memory with a variable name. Guidelines for naming variables. As such, variable name can be anything, but still there are certain rules to be followed. So a variable name must begin with alphabet, underscore, or $sign. Whenever you create any variable name, it must begin with alphabet, underscore, or $sign. Till possible, in most of the cases, we start variable name with alphabet only. It cannot have blank space, and it cannot be a reserved word. So it cannot be there cannot be blank space. So it's a single word, and then it cannot be a reserved word of Java. Like I cannot create variable name like int. I cannot create variable name as char or static, etc. Because all these words are having some special meaning in Java language. Java allows variable names of any length. So there is no as such restriction that how lengthy your variable name is. but it is customary to begin it with lowercase letter. It is customary that we create variable name starting with lowercase letter. Variable names are case sensitive. So case sensitive means, in fact, entire Java language is case sensitive, including variable names. They are case sensitive means small a and capital A are considered as two different variables. So if you declare variable name a with small a, and then somewhere in your program you use that variable as capital A, it will give you error because they both are different things. There are two methods for naming variables which are made up of more than one words. Now when variable is made up of more than one words, then there are two methods. One method is where you capitalize every word's first character except first word, like birth date of candidate. So except birth, as we discussed that it is customary to begin variable name with lowercase letter. So birth will be small letter, but then rest of the words, that is date, of, candidate, should have first character as capital letter. Similarly, total room door, or there is another method, birth date of candidate, you separate each word using underscore sign. Total room door, separate it using underscore sign because blank spaces are not allowed. So you can follow any of the method, either capitalizing the first character of every word except first word, or by separating each word using underscore sign. So these are the two popular methods followed for naming variables having more than one words. Java literals. What are literals? Literals are nothing but constant. It is called constant. So a name used for a constant value is known as literal. There are four types of literals in Java. So there are four different types of constants in Java, like numeric literal, character literal, Boolean literal, and string literal. Numeric literal. Now let us discuss one by one. Numeric literals, they represent integer literal as well as real literal numbers. For example, if I write 1702, it's an integer literal. But if I write 16.05, it's a real literal. So a numeric literal represents both integer as well as real numbers. Boolean literals are true and false. That's it, nothing else. So Boolean literals are true and false, again in small case letter only, no capitalization. Character literals are expressed by single character surrounded by single inverted comma. We already discussed that. But there are some backslash characters to represent non-printable characters, like \n for new line. So there are two characters written, remember. Now if you observe it, within inverted comma there are two characters, \and n. But remember, these are special characters which are non-printable character. Non-printable character means which we cannot type on screen. If I want to type enter key on screen, is there any way? No. If I want to type shift key on screen, we cannot type shift key, caps lock key, control key, alter key, tab key, enter key, escape key. All these key are non-printable characters. So they can be represented using a formula or format called \ followed by character. So \n is for new line, \t is for pressing tab, and so on. String literals are written between double inverted comma. So these were the basic about all the four literals: numeric literal, character literal, Boolean literal, and string literal. Now we will see all these literals in detail. First we begin with numeric literal, and in that integer literals. Integer literals represents whole numbers. You know it now. Java allows decimal, octal, binary, and hexadecimal and Unicode integer literal. So Java allows all these different types of numbers to be used while using integer literal. Decimal, that is one which we are using normal numbers with base 10. Octal number system, where the base is 8 And I hope you understand that octal number system means it has only 8 digits in its number system. 0, 1, 2, 3, 4, 5, 6 and 7. 0 to 7. That's it. Binary is very popular, so you would be knowing that binary is base 2 and there are only 2 digits, 0 and 1. There is nothing after 1 in binary number system. As we, in our number system, decimal number system, we have 10 unique digits, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. After 9, we don't have anything unique. After that, everything is combination of previous digits. Like after 9, we have 10. So it is combination of 1 and 0 and so on. Similarly, in octal number system, there is nothing after 7. It is only 0 to 7. There is nothing like 8 and 9. After 7, it uses only the old digits. Similarly, binary has got only 0 and 1. There is nothing after 0 and 1 in binary number system. 2, 3, 4, 5, 6, 7, 8, 9 જેવું કશું જ નથી binary number system માં. Hexadecimal number system is bigger number system than even decimal with base 16. And there are 16 unique digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So 0 to F. And then we have Unicode integer literal, which we will discuss further in this chapter. Ordinary integers such as 34, 988, 14, 10, 69 or minus 1605 are decimal integer literal. They are all decimal integer literal of type byte, short or integer. A decimal integer literal larger than integer is automatically of type long. So the decimal integer literal where the size is bigger than integer, the range of integer we have seen in the table, if bigger than integer, it is automatically of type long. We can force a smaller number to be long by appending small or capital L as a suffix. So sometimes suppose you want number 34. Number 34 is a very small number. It can be of byte also, it can be of short also, it can be of integer also or anything. But if you want to say that this 34, number 34, you want to treat it as long, then you should write 34L, small or capital L. Negative integers are preceded by a minus sign. So whenever you want to write some negative integer literal, you precede them with minus sign, which is very simple thing. Octal numbers. Octal numbers use only digits from 0 to 7, as I said. That is only 8 different digits. In Java, a numeric literal with a leading 0, any number with leading 0 is interpreted as an octal number. For example, literal 045, if you write somewhere in your program 045, then that 045 is not considered as number 45, but it is octal number 045, where its decimal value is 37. That is, in our number system it is equal to 37, but in octal it is written as 045. Here it is very important to understand that there cannot be an octal number like 087, 099, 019, etc. Are you getting this? Why it is not? Because octal number system is only from 0 to 7. There is no digit like 8 or 9 in octal number system. So how can be 087 be valid number in Java? Because when you precede any number with 0, Java compiler understands that number as octal number. And once it treats it as octal number, there cannot be 8 or 9. And that is why all these three are invalid number. 087, 099, 019. All these numbers are invalid, as digits 8 and 9 are not part of octal number system. When a number is written with leading 0, remember it is considered as an octal number. Hexadecimal numbers. Hexadecimal numbers uses 16 digits, usually digits from 0 to 9 and the letters A, B, C, D, E and F. It can be uppercase or lowercase letters can be used interchangeably. So You may write small a, b, c, d, e, f, or you may write capital A, B, C, D, E, F. We have already seen in previous example also. The letters A to F is actually representing number 10 to 15 of decimal number system. So F is equivalent to 15 and A is equivalent to 10. In Java, a hexadecimal literal begins with 0x or 0 capital X. So whenever any number beginning with 0x or 0 capital X, Java compiler treats that number as hexadecimal number. For example, 0x45, 0xA7B9, as you see, because A, B, C, D, E, F is part of hexadecimal number system. So it is a valid number. Or 0xFF00FF. Generally, hexadecimal numbers are used for color, describing colors, different colors. And the last example which you see, 0xFF00FF, it is used to represent a combination of red and blue color, because first two digits are representing red number, second two digits represents green number, and last two digits represents blue number, RGB. So R, that is red, is full, FF, that is the biggest, because F is the biggest number in hexadecimal. So FF is biggest, highest red color. 00, so green is totally absent. And again FF means blue color is fully present. So whatever will be the combination of pure red and pure blue color would be the resultant color. Hexadecimal numbers are also used in character literals to represent any Unicode character, and we will see some example. A Unicode character literal consists of \u, where \u indicates that it's a Unicode character followed by 4 hexadecimal digits. For example, character literal \u00E9. Now, before again we complete this sentence, you must remember that character literal, I told you that there should be only one character within single inverted comma. But if you see here, it is having 6 characters, \u00E9. Then how come it is possible? It is possible because keyboard has got very few characters to type, and character literal is able to represent more than 65,000 characters. Gujarati character, Sanskrit character, Malayali character, Spanish character, Japanese character, Urdu characters, so many different characters. Then how to represent all these characters? So to represent all these characters, there are Unicode numbers given. So \u00E9 is used to represent E with acute accent. What is acute accent? There will be some line on E here, that is acute accent. You can search for acute accent character. Actually I forgot to display the same character here, but E, on the top of E there will be a line, small line, that is called acute accent. And \u2122 is used to represent trademark symbol. Only these two examples of character literals are given in textbook. So board is asking only these two. So remember this two code, \u00E9 is for E with an acute accent, and \u2122 represents trademark symbol. Binary numbers. Java 7 also supports binary numbers, and binary number system uses only 2 digits, 0 and 1. There is nothing like 2, 3 or anything. In Java, binary numbers are preceded by 0b or 0 capital B. For example, literal 0b101 represents binary number whose decimal equivalent value is 5. But because 5 cannot be written in binary, so we have to write 5 in binary format, and it is written as 101. Here it is very important to understand that there cannot be a binary number like 0b1022 or 0b1018, and now I hope you will be knowing that why it is not possible. Because binary number system, when we precede any number with 0b, it is binary number. So it can have only 0 and 1. There cannot be 2 or 8 or anything. So since digit 2 and 8 are not part of binary number system, they are totally invalid number and compiler will give error. Real number literal. So this what we completed is integer literal. Integer literal, and in integer literal we discussed about decimal. We didn't discuss because decimal number so we are using in day-to-day life, but we discussed octal number, hexadecimal number and binary number. Now real number literals. Real number literals are also called floating point literals and can be represented using two types of notation, scientific notation and standard notation. Standard and scientific notation are the two different types of notation where we can represent number with decimal point. In standard notations, the integer part and the fractional part are separated with a decimal point. For example, 14.10, 17.02, 16.05, etc. In scientific notation, a number is followed by letter E or capital E and a signed integer exponent. For example, 1.3 E plus 12, 12.373 E minus 16. So E is for exponent. E is for exponent, which is 10 raised to. So this means that 1.3 10 raised to 12, 12.37 12.373 into 10 raised to minus 16. So here E plus 12 and E minus 16 represents power of 10. In Java, floating point literal by default is of type double. So whenever you write any number with floating point like 2.5, so it is double. By default its data type is considered as double. To make a floating point literal of type float to save memory, when you are sure the floating point number which you are using is not very big, which requires double data type, because double data type occupies 8 bytes of memory and float occupies 4 bytes of memory, then to save memory we can forcefully say that 1.2 f or 1.2 small f. That means now 1.2 will occupy only 4 bytes of memory and it is considered as floating point number. But if you write only 1.2, then it will be treated as double and it will occupy 8 bytes of memory. So this specifies that 1.2 to be considered as float type of value. Boolean literals. For the type Boolean, there are precisely two literals, true and false. These literals are to be written without inverted commas. Boolean literals represent values and not variables. They represent some value, that is true and false. Boolean value occurs most often as the result of conditional expression. When we write some conditional expression, it will result a Boolean value. For example, conditional expression 5 greater than 16. So it will result either in true or in false. So you know that 5 greater than 16 will result false. In C language, 0 is treated as false and non-zero value is treated as true. That was in C language. We are not supposed to discuss C language, but because this sentence is given in textbook, so they might ask in board exam. So I have covered that sentence here in the PPT. Whereas in Java, literal true and false are not associated with any numeric value. Remember, in C, Boolean value are related or they are associated with numbers 0 and non-zero. Whereas in Java, true and false Boolean values are not associated with any numeric value. Character literals. Character literals are expressed by single character surrounded by single quote like this. We already discussed many times. Characters are stored as 16-bit Unicode characters. Certain special characters have special literals that uses a backslash as an escape character. And you can see the list of character \n for new line, \t for tab, \b for backspace, and so on. So you can go through this table to understand things. String literals. A string literal is a sequence of characters enclosed within double inverted commas. Compiler don't look at what is written between double inverted comma. It may be some meaningful or meaningless. You can write anything within double inverted comma. Compiler will not give any error. They are just ignored by compiler and they are just used to be printed or saved in computer. So compiler will not look at that. Within a string, special characters can be represented using a backslash notation, as we show it in the previous screen, like backslash character, using this backslash character. For example, to represent string value many congratulations, if I want to represent string as many and then congratulations I want to represent within double inverted comma, then how to do? Then we need to type the string literal as double inverted comma many backslash inverted comma congratulations backslash double inverted comma and then double inverted comma over. Here first and last double inverted commas indicates beginning and end of string. You know that string literals are written within double inverted comma. So the very first inverted comma and the last inverted comma, double inverted comma, indicates beginning and end of string. And slash, that is backslash double inverted comma, indicates that those double inverted commas are part of the string and is to be printed whenever it is printed as the output. So it will print many and then it will print congratulations within double inverted comma. So simply you remember that whenever you want to use any special character to be printed, it should be preceded by backslash. The comments in Java. Comments in a program are for human reader. So as we discussed I think this topic, comment topic, so many times. I think we discussed it in while discussing JavaScript also, while discussing HTML also, because every programming language or every program can contain comments, but that comments has nothing to do with the performance of the program or the output of the program. It is only for human. They are entirely ignored by the compiler. So comments makes the program easy to understand for everyone reading the program code. It is only for again those who are reading your original program coding, or you yourself is reading your program after few years or few months. So that if you've written comments, it becomes easy for you to understand that what the following things are doing. So as in case of this program which we have seen long back in when we started chapter 7, so all these are comments. So as you see here, it says declare variables. That means now next statements are declaring variable. Computation means now next session is doing some computation. Display results means now next statements are displaying the result. End of main, so indicates that this closing curly bracket is indicating end of main method which begin here. And end of class call cost means this class call cost which started here with opening curly bracket is getting over here. So this comment makes your program readable, easy to understand for the one who is reading your program or your own program when you are reading. So comments are that way very important. Java supports three types of comments. Single line comment that begins with double slash, multi-line comments that begin with slash star and end with star slash, and then there is third type of comment that is called documentation comments, which begins with slash double star and ends with star slash. They are used now. Documentation comment they are used to create API documentation from the code. API is application programming interface. It is only when you are designing or developing a big software and then you want to create your documentation of your software, then API, that is application programming interface document, that comment can be written, which are used by Java doc system, can be created using slash double star and it end with star slash. So remember, these are the three types of comments in Java language. One more thing about comment is comments cannot be nested. Means you cannot write another comment within another comment. Comment cannot be nested. Expressions. Expressions are essential part of programming language. Any programming language, expressions are essential part, the important part of programming language. The basic building blocks of expression, that how expressions are created. So the basic building blocks of expressions are literals, that is constants, variables and function calls. Literals and variables you know, function calls right now you may not be knowing, but we'll discuss it afterward. Simple language, function calls means calling a function with some value. For example, in Excel, we say is equal to sum into bracket 10, 15. So that 10, 15 is the argument of the function sum. More complex expressions can be built up by using operators to combine simpler expression. So you write simple expression and then you combine it using different operators to make it a complex expression. When several operators appear in an expression, there is a question of priority. So when there are many different operators used in an expression, there is a question of priority, that which operators should be and how that operators are grouped for evaluation, which should be executed first and how they are grouped for evaluation. So parentheses, that is brackets, can be used to explicitly specify the grouping. Like if you say 6 plus 4 in bracket, that means you are grouping it together so that it will be done first before doing division. So that is what grouped for evaluation. Now operators. One of the most interesting topic of chapter 7 is operators. Operators are special symbol used to build an expression. Java supports many different types of operators as follow. And remember, all these 7 different types of operators we are going to discuss in detail. But let us see what are the different types of operators. First one, arithmetic operators. Arithmetic operators are used for arithmetic expression, and the operators, there are 5 operators: plus, minus, multiplication, division and percentage, that is called modulo operator. We will discuss in detail next slide. Comparison operators. There are 6 comparison operators: double equal, that is for equality; exclamation equal, that is for not equality; greater than, less than, greater than equal to, and less than equal to. Logical operators. There are 4 logical operators: AND indicated by double AND, OR indicated by double pipe, exclusive OR indicated by caret sign, and NOT indicated by exclamation sign. Again, AND and OR we discussed while discussing JavaScript for validating form in chapter 2. Fourth, conditional operator. Conditional operator is made up of 2 operator, question mark and colon. Assignment operator, that is equal sign, simple. Increment and decrement operator, that is plus plus and minus minus, used to increase value by 1 or decrease value by 1. Shorthand operator, that is plus equal, minus equal, multiply equal, slash equal, percentage equal, and equal, and like that. So that is shorthand operator or shorthand assignment operator. Now let us discuss all these operators in detail. Arithmetic operators. Plus, minus, multiplication, division and percentage, that is modulus, are basic arithmetic operators. All these operators are binary operator taking 2 operands. Binary operator means if you want to use multiplication sign, you need to give minimum 2 numbers, 8 multiplied by 5. But if you just simply write 8 multiplied by, then nothing if you write, it is incomplete, invalid. So it requires 2 operands, and that is why it is called binary operators. But operators plus and minus can also be used as unary operator taking only 1 operand. If you write plus 85, it is not incomplete. If you write minus 76, it is not incomplete. So plus and minus can also be used as unary operator. Percentage modulus operator is used to find remainder. Now remember, percentage, that is modulus operator, it is doing division only, but answer what it gives is the remainder. For example, if we write 14 percentage 5, then first what it will do is it will divide 14 by 5, like division operator. But then answer it will not give 2, rather it will give 4, because 5 2s are 10, 14 minus 10, remainder is 4. So percentage sign is a modulus operator and it is used to find remainder. All these operators can be used by all numeric data types like byte, short, integer, long, float and double. So all these 5 can be used by all these 6 data types. They can also be used with value of type character, because if you remember while discussing data types, I told that character data type is internally it is stored as number, because every character is associated with a Unicode number. So they can also be used with value of type character. All these arithmetic data types can be used with the type character, and with character type of data their Unicode numbers are used for calculation. Comparison operators. Comparison operators are also known as relational operators because it shows relationship between LHS and RHS. The comparison operators are all these 6 which we already discussed. These comparison operators are used to compare values of any type, any of the numeric types as well as of character type. So like arithmetic operator, comparison operators also can be used by all the numeric data types, that is byte, short, integer, long, float, double, and it also can be used by character data type. After applying comparison operator, so while using comparison operator, the result of expression is always Boolean, and that you should know, because comparison means answer will be true or false. Mahesh is taller than Ramesh. Yes or no, true or false. There cannot be any other possible answer. So comparison operator when used in an expression, result will be always Boolean, that is either true or false. So such expressions are also known as Boolean valued expression. So wherever we are using comparison or relational operators, that expression is also known as Boolean valued expression. Usually relational operators are used within if statement and loops, which we'll again discuss further in this chapter. So these are the comparison or relational operator. Once again, you should understand that whenever using comparison operator, answer will be always Boolean. For example, my height, maths marks are greater than your math mark. So greater than, true or false. Either it will be true or it will be false. So comparison operator always results in Boolean answer. Logical operators. Logical operators are also called Boolean operators because they are also resulting in true or false. In Java, there are logical operators like AND, OR, exclusive OR and NOT, and they are performed using the operators double ampersand sign, double pipe sign, caret sign and exclamation sign. Boolean operator AND is used to combine two Boolean values for logical AND operation, and the result of expression A and B is true only if both the operands A and B are true, otherwise it results false. So in physics you might have done logic gates, and this is same as logic gates. AND gate, you know AND gate, when both the condition on AND on left hand written on both the side are true, then only the answer is true. The final statement is true, otherwise it is false. So let us see the example. Example 1, 11 greater than 5 and 78 less than 99. Both are true, both the conditions are true. So true and true is equal to true. Second example, 78 greater than 100 and 15 less than 99. First condition is false, second is true. So false and true is false. Third example, 100 greater than 51, true, and 100 less than 500, which is false. So true and false, again false. And last example, 100 is less than 10 and 100 is less than 20. Both are false, false and false, false. So as you can see, it is only true when both the conditions are true, rest it is false. Boolean operator for logical OR is double pipe, two vertical lines known as pipe. OR is used to combine two Boolean values for logical OR operation. The result of expression A or B is false only if both the operands A and B are false. Otherwise, it results true. So let us see again example. Again, you must be knowing logic gates OR, that in OR, if both the conditions are false, then only the result is false. Otherwise, it is true. So 111 greater than 55 or 78 less than 99, both are true. So it is true. 78 greater than 100 and 15 less than 99. First condition is false, but second is true. So false or true, it is true. 100 greater than 51, 100 less than 500, it is true because one condition is true. 100 is greater than 51. And fourth example, 100 less than 10, 100 less than 20. Both are false. So the result is false. So as you see, with OR, when both the conditions are false, then only the result is false. Otherwise it is true. Boolean operator for logical exclusive OR is represented using caret symbol. Caret is used to combine two Boolean values for logical exclusive OR operation. The result of expression A exclusive OR B is false. Understand this very clearly. This is something different. The result of expression A exclusive B is false when both operands have same value, and true when both operands have different values. For example, 111 greater than 55, exclusive or 78 less than 99. So both the conditions are true. When both the condition, read the third point again, is false when both operands have same value. Here both the operands have same value, true, true. So the result is false. Whereas second example, 78 greater than 100 is false and 15 less than 99 is true. So when both operands have different value, one is having false and one is having true, then answer is true. 100 greater than 51 exclusive or 100 less than 500. So here first condition is true, but second condition is false. So it is true because both the operands results different. And the last one, 100 less than 10, which is false, exclusive or 100 less than 20, which is also false. So both the operands are resulting false. So the output is also false because they are same. So remember, in exclusive OR, if one condition is true and one condition is false, then answer is true. But if both the conditions are true or both the conditions are false, then answer will be false. That is exclusive OR. Boolean operator for logical NOT is denoted by exclamation sign. It is a unary operator which works only on one operand. Logical NOT results in complemented result. So it gives you complemented result. Means if the operand is true, result is false. And if the operand is false, then the result is true. If true, then false. And if false, then true. So NOT 1 greater than 100. Now 1 greater than 100 is false. But NOT 1 greater than 100 is true. Because NOT false is true. and 100 greater than 1, not 100 greater than 1 is true, but not 100 greater than 1 is false. So not true is false. So it gives complemented result, that is if the statement is true it gives false and otherwise. So that is what logical operator not. So all these were logical operators. Now there is something called short circuiting. Now what is short circuiting? While using logical operators and or, Java does not evaluate the second operand or second condition unless it is necessary to get the result. So in certain situation or certain case, there is no need of evaluating second condition. And result, it means why it is not required, because it will not make any difference on the output. So if the first operand, remember this point is very important to understand. If the first operand is false in case of AND, there is no need to evaluate the second operand. Similarly, if the first operand is true in case of OR, there is no need to evaluate the second operand. This situation is called short circuiting. For example, 5 greater than 11 and 15 greater than 5. Now 5 greater than 11, first operand, first condition itself is false. So there is no need to evaluate 15 greater than 5. Whether it is true or false, output will be false only. Similarly, in case of OR, if I say 15 greater than 5, which is true, then there is no need to evaluate second condition, because second condition is true or false, it doesn't make any difference. So in both the above example, the second operand is not evaluated, and that is called short circuiting. So that is short circuiting topic is something related with logical operators. Conditional operator. The conditional operator in Java is a ternary operator. Why it is called ternary operator? Because that operator is using 3 operands and it is made up of 2 symbols, question mark and colon. The format of conditional operator is we write Boolean expression, then we put question mark, then we write expression 1, colon, expression 2. Remember, conditional operator is same as if then else. So here first the Boolean expression is evaluated, and if its value is true, the Boolean expression whatever you write, if its value is true, then expression 1 is evaluated, and if it is false, then expression 2 is evaluated. For example, answer is equal to n percentage 2 is equal to 0, comparing. Question mark n divided by 2, colon 3 multiplied by n plus 1. Now what we are doing here, if the value of n is 8, so if you put 8 at the place of n, then 8 percentage 2, remember percentage operator, it is for finding remainder. So 8 percentage 2, that is 8 divided by 2, remainder is 0. So condition is true. So the expression, first expression, Boolean expression is resulting in true. And since it is true, it will execute expression 1, and that is n divided by 2. So 8 divided by 2, and the answer will get the value 4. If the value of n is 9, then 9 percentage 2, the remainder is not 0, remainder would be 1, because 9 divided by 2, 2 4s are 8, 9 minus 8, 1. It gives remainder 1. Modulo operator, percentage operator, it is giving you remainder. So remainder is not 0. So the test expression, Boolean expression, n percentage 2 is equal to 0 is false. And since it is false, it will evaluate the expression written at the after the colon sign, that is 3 multiplied by n plus 1. So it will do 3 multiplied by 9, that is 27, plus 1, that is 28. So answer will become 28. I hope you understood this conditional operator. Remember, conditional operator is not much used by programmer in their programming, because we already have if then else, which is more meaningful and more easy to understand and easy to write in your program. So mostly programmers avoid using conditional operator. Now the next is assignment operator. In Java, an expression containing assignment operator, that is equal to sign, is generally referred to as assignment statement. So wherever there is equal sign used, single equal sign is used, it is an assignment statement. Once a variable is declared, you know that we declare variable, if you remember that first program. So there were variables like double balance, double call cost, and like that. So those are the declaration of variable. So once a variable is declared, we can assign a value to that variable using assignment operator. So you can assign value to a variable only if that variable is declared. So the format of assignment is, we write variable name, we put assignment operator, that is equal sign, and then we write some expression. Either we write some constant value or we write some expression. So here expression represents anything that refers to or computes to a data value which is assigned to variable. What does it mean to say is, if you write a is equal to 10, so 10 is a constant value which will be immediately assigned to variable a. But if you write a is equal to b plus c plus d divided by 6, then first this expression will get evaluated, and then whatever is the answer, that answer will be assigned to the variable. So that is what assignment statement is used to assign value to LHS, that is whatever is written on the left hand side. The type of expression on the right hand side of an assignment statement should be the same as the type of variable on the left hand side. This is again very important for you to understand. What it says is, when you say a is equal to 10, then variable a, if the variable a is declared as type byte, and if you are assigning value as 10.5, then it's an error, because variable is of type byte where it cannot store value with decimal point, and you are trying to assign value with decimal point. Even for integer, if you say integer a, so variable a is declared as integer, and then if you write a is equal to 8.7, which is again wrong, because integer cannot hold number with decimal point. So the fourth point, what it is highlighting is that the type of expression on the right hand side of an assignment statement should be same as the type of variable on the left hand side. And if the data type of expression is larger than the variable on left hand side, it may result in an error. So if you try to assign integer value to a byte value, it will result in error. Or if you try to assign a float value to integer value, it will create an error, or it will generate an error, because we are trying to accommodate bigger value in a smaller bag. Or it is something like, okay, we are on a shopping where we want to shop so many things, and we are having only one small plastic bag which is not capable enough to keep everything what we are purchasing. So that is what the last statement says, it will generate an error. However, if the data type of both the sides are not matching, then the value of expression is automatically converted to match the type of variable. But that doesn't happen every time, remember. So it says that if the data type of both the sides are not matching, then the value of expression on the right hand side is automatically converted to match the type of variable on left hand side. But there may not be automatic conversion. In certain cases, there may not be automatic conversion. For example, integer to short will not get converted. Double to float will not get converted automatically. That means if on left hand side, that is on left hand side of assignment operator, variable is of type short, and the result of expression on right hand side is of type integer, then that will not be automatically converted. So mathematically, there is now one very interesting thing to understand, that mathematically what you see here is not possible, that balance is equal to balance minus cost. Mathematically, nobody in the world can prove this as true, because balance cannot be balance minus cost. Balance will be always balance, no plus, minus or nothing. 5 will be always 5. 5 cannot be anything else. So here, how this statement is then interpreted by computer. This kind of statement is possible in computer but not possible in mathematics. Let us understand what happens actually. Here expression balance minus cost, that is expression on right hand side, is first evaluated using the existing value of balance. Suppose the existing value of balance is 500 and cost is 100, then it will do 500 minus 100, and thereafter the resulting value is placed in the variable balance, replacing older value which is on the left hand side. So balance now will be reduced by 100, whatever is its original value. From that value it will be reduced by 100, and then new value will be again stored in the variable balance. But still, the last point will clear your doubts, that what is the difference between the balance on left hand side and the balance written on right hand side. Let us see that. Actually, variable on RHS, that is on right hand side balance, refers to the value stored in that variable. So the balance minus cost, that balance refers to the value which is stored in balance variable. Whereas variable on LHS, that is the balance written before equal sign on left hand side, refers to its memory location where that value is stored. So that is why in computer this is possible, but mathematically this cannot be proved. So the balance on left hand side refers to the memory location of the variable balance, and balance on right hand side refers to the value stored in balance variable, and that is why this is possible. Shorthand assignment operator. Now there is something called shorthand assignment operator, which also I think we saw in chapter 2 or chapter 3. Java also support shorthand version of assignment operator. Shorthand assignment operator saves typing time and reduces common typographic error. The main purpose of using shorthand assignment operator is to speed up your programming and to reduce common typing error. It takes the form variable, operator. It can be many different operators, arithmetic operator, logical operator, many different operators. So variable, operator, assignment, that is equal sign, and expression. It's same as variable is equal to variable operator expression. So both are, the result will be same. But what is the advantage we will see? Let's say we see the example only. For example, a is equal to a plus 3. That is a normal statement that says variable is equal to variable plus is the operator and expression is 3. So a is equal to a plus 3. But it can be written using shorthand assignment operator as a plus is equal to 3. Now you might wonder that then what is the difference there? In the first one we need to press 5 key. A is equal to a plus and 3. 5 key. And the next one we need to press only 4 key, that is a plus is equal to 3. So why to use this? But this is more useful when the variable name is not as small as like this a. Suppose the variable name is total number of students in Saurashtra University. Suppose the variable name is total number of students in Saurashtra University. Now think of this. If you use the normal method, you need to write total number of students in Saurashtra University is equal to total number of students in Saurashtra University plus 3. But if you use the shorthand assignment operator, you need to write only one time total number of students in Saurashtra University plus is equal to 3. So it will reduce typographic error while typing a long lengthy variable name. Again, you don't need to type it twice, you just need to type once. So that is the main advantage of using shorthand assignment operator. Let us see some more example of shorthand operator. If you write balance is equal to balance minus cost, that can be written as balance minus is equal to cost. Marks is equal to marks divided by 10 can be written as marks divided is equal to 10. Number is equal to number modulo 5. It can be written as number modulo is equal to 5. Answer 1 is equal to answer 1 and answer 2 can be written as answer 1 and is equal to answer 2. So you can see that it reduces the typing time. You don't need to type the variable name twice, so that it saves typing time, as well as there are less chances of typographic error. So that is what shorthand assignment operator. But remember, it is not compulsory to use shorthand assignment operator. If you are not comfortable and if you feel that your variable name is too small, so you can follow the normal method also. Next operator is increment and decrement operators. They are unary operator. They work on only one operand. So operator, unary operator plus plus and minus minus are called increment and decrement operator respectively. Plus plus adds 1 to a variable and minus minus subtracts 1 from a variable. So whenever it is used with variable, plus plus will increase value by 1 and minus minus will decrease value by 1. But remember, that doesn't mean if you type 3 times plus 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 plus, that will increase value by 2, or you say minus 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 will decrease value by 2. No, there is no such operator. It is only plus plus and minus minus to increase by 1 or to decrease by 1 from a variable. It can be used by byte type of data, short type of data, integer type of data, long type of data, and character type of data. So these 5 data types can use this increment and decrement operator. Now when plus plus or minus minus is used before variable name, now see, there are 2 variations of plus plus and minus minus, or there are 2 variations of increment and decrement operator. So when they are used before variable name, it is known as pre-increment or pre-increment or pre-decrement operator. And when plus plus or minus minus is used after variable name, it is known as post-increment or post-decrement operator. We will see in detail what is the difference between pre-increment and post-increment, and difference between pre-decrement and post-decrement. When these operators, the last point, when these operators are used in a standalone statement, now you first need to understand what is a standalone statement. Standalone statement means there is nothing except one operator, and that is either increment or decrement operator. There is no other operator used. So when these operators are used in a standalone statement, use of pre or post does not make any difference. That means, for example, a plus plus, which is called post increment, and plus plus a, that is called pre-increment, are same, but only same when they are used as standalone. If they are used with some other expression, other operators, then they have different meaning. So are same and will increase value of a by 1, and they are called standalone statement. Now let us see in detail what is pre-increment, pre-decrement, and what is post-increment and post-decrement. So the first one, pre-increment and pre-decrement. Pre-increment and pre-decrement, when plus plus or minus minus is used in an expression before variable, it is called pre-increment or pre-decrement respectively. So as I said here, the second one here, this one, plus plus a, where increment operator is used before variable. So when they are used before variable, it is called pre-increment. Here the value of variable is increased or decreased first, and then they are used in the expression. Now remember, the best example to understand pre-increment and post-increment, or pre-decrement and post-decrement, is to understand or compare it with mobile prepaid and postpaid plan. When we say I have prepaid mobile, that means I have paid money first and then I am using the service. When I say I have postpaid plan, that means I am using the service first and then at the end of my billing cycle, I am paying the bill. So in both the case, payment is done, remember. In both the case, prepaid or postpaid, payment is done. But at what time payment is done is important. Similarly, pre-increment and pre-decrement value will increase or decrease, but it will increase before using. Whereas in post increment and post decrement, value will increase, but it will increase first it is used, the old value is used, and then value will increase or decrease. Let us see some example. Right now we will see the example of pre-increment and pre-decrement. So for example, if variable x is equal to 10 and if variable y is equal to 15, then writing z is equal to plus plus x minus plus plus y. Now here operator increment operator is used before variable name. So because it is used before variable name, it is called pre-increment. And when it is pre-increment, variable value of variable is increased first and then they will be used. So what will happen? First x will become 11, y will become 16, and then what it will do is it will do 11 minus 16, so the answer would be minus 5. Second example, again if x is equal to 10 and y is equal to 15, then z is equal to minus minus x plus minus minus y. Here also x and y are having pre-decrement. Pre-decrement means first value will decrease. Prepaid, first we make the payment and then we use the service. Similarly, pre-decrement and pre-increment value will be decrease or increase first and then it will be used. So here they are both are pre-decrement. So first value will decrease. So x will decrease to 9 and y will decrease to 14, and then they will be added 9 plus 14, which will be 23. So answer would be 23. So this is pre-increment and pre-decrement. Post-increment and post-decrement. When plus plus or minus minus is used in an expression after variable now. When it is used before, it is called pre. When it is used after, it is called post-increment or post-decrement respectively. Here, what happens? Here the old value of variable is used in the expression, and after the expression is settled, the value is increased or decreased. So here what happens in post-increment and post-decrement, first we use the variable value, the old value, existing value. And once the expression is settled, then after value will be increased or decreased. So when that variable used in next expression, the increased or decreased value will be used. Let us see some example. For example, suppose a is equal to 25 and b is equal to 8. Then writing c is equal to a plus plus minus b plus plus. As you can see here now, it is post increment. Post increment means value will not increase right now. First old value will be used. So old value, that is existing value of a is 25 and b is 8. So a is 25, b is 8, and 25 minus 8 will give you 17. But once c becomes 17, after that a will become 26 and b will become 9. And if a and b are used somewhere after this statement in your program, then a would be 26 and b would be 9. So that is called post increment. Similarly, second example, considering if a is equal to 25 and b is equal to 8, then c is equal to a minus 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 b minus minus. They are post decrement. Now in this statement, first the expression gets evaluated with existing value, that is 25 minus 8, which will give you 17. So once c becomes 17, once 17 is assigned to variable c on left hand side, Once C becomes 17, then A will be reduced to 24 and B will be reduced to 7 respectively. So after this, if A or B used somewhere else in your program, they will be 24 and 7 and not 25 and 8. So that is post increment and post decrement. Very interesting operator. Let us see some more example to understand. Example 1. If A is equal to 25, B is equal to 8, then C is equal to plus plus A minus B minus minus. Now here I have mixed both. Plus plus A is pre-increment. So value of A will increase first, whereas B minus minus is post-decrement. So value of B will not decrease. Rather, first expression will be evaluated with existing value. So 26 minus 8, which will give you 18. Because it was pre-increment, so A became 26 from 25. But because B is having post decrement, so B value is not changed and existing value is used. So 26 minus 8, which we will get as 18. So C will become 18. But once the expression is settled, then B will be decreased by 1 and becomes 7. So now if B is used in any other expression, then its value would be 7 and not 8. And A would be 26. Another example, if x is equal to 10, y is equal to 5, then z is equal to x minus minus plus 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 y. So here x minus minus is post decrement. So the value of x will not decrease first. It will not be decreased first. And plus plus y is pre-increment. So value of y will be increased first. So y will become 6. But x will remain 10. So 16. Now once the expression is settled, that means once z gets the value 16, then x will be decreased from 10 to 9. And now x, if it is used somewhere in other expression, then its value would be considered as 9 and not 10, and y would be 6. Compare this operator with prepaid and postpaid mobile plans and you will understand it very clearly. It says that compare this operator with prepaid and postpaid mobile plans and understand when user has to make payment. So it is like same as prepaid and postpaid mobile plans. Typecast. Now there is something called typecast. In some cases, we may want to force a conversion which is not done automatically. You know that there sometimes conversion is done automatically. While settling the expression, compiler tries to convert lower data type to higher data type automatically. But in certain cases, we want to force a conversion which is not being done automatically. And for this, what we can use is called typecast. So a typecast is indicated by how it is indicated. So it is indicated by putting a data type in brackets before the value we want to convert. Whichever value you want to convert, before that you write the data type in which you want to convert in a round bracket. So it takes the form within round bracket, we write the data type and then the expression. So for example, suppose integer a and short b. These are the two variables. A is equal to 17 and b is equal to, if I want to assign same value of a to variable b also. But if I simply write b is equal to a, you know that it will generate error. Because why? A is integer and b is short. So RHS is bigger in size than LHS. So it cannot go. It is something like I have something stored in a very big bag and that I want to keep in small bag. It will not go because the bag size are different. But here what now we are doing is we are forcefully reducing the size of A from integer to short by using typecast. So we say B is equal to into bracket short A. So temporarily A will become short data type. It will become data type of short and then value will be assigned to B but then after again a will become integer. So here variable a is explicitly converted using typecast to the value of type short. This is a temporary change, and after this statement again a takes its original data type, that is integer. So this is what we call typecasting, where we forcefully convert a data type which is not being done automatically. Precedence now. Java has well-defined rules for specifying the order in which the operators in an expression are evaluated when the expression are having several different types of operators used in it. So maths we have BODMAS rule. So in maths we have BODMAS rule, but you know that in computer there are so many operators. So which operator has got higher precedence, higher priority, and which has got less? So that is what this topic is all about. So the operators are evaluated as per their priority, their precedence. When two operators are having different priority, then the operator with higher precedence or higher priority is operated first, which is again very simple. We know that multiplication has got higher priority than addition. So if I am writing 8 plus 8 divided by 5, then first it will do 8 divided by 5 and then answer will be added in 8. But because why it happens? Because division has got higher priority. So for example, in expression 4 plus 6 multiplied by 2, because multiplication has higher priority or precedence than addition, so 6 multiplied by 2 is evaluated first, and then the result is added to 4, giving output as 16, because 6 2s are 14, 12, 12 plus 4, 16. Precedence rules can be overridden. If you want to change this order, then it can be overridden by explicit use of parentheses, that is brackets. So if we write into bracket 4 plus 6 and then multiplied by 2, we'll first do 4 plus 6 now because BODMAS rule. So bracket will be evaluated first. So now it will do 4 plus 6 first, which will result in 10, and then it will multiply it by 2, giving output as 20. So that is what precedence or priority. Similarly, there is something called associativity. When two operators with same priority, same precedence appear in an expression, it is something like for admission. There is only one seat and there are 3 students with same percentage. Then what to do? Same here. When more than one operators with same priority appear in an expression, the expression is evaluated according to its associativity. So what is associativity? Associativity determines the direction, whether left to right or right to left. In most cases, associativity is from left to right, but for unary operations, assignment operator, it is from right to left. Remember this because board is quite often asking this thing. Example we see, if I write A is equal to B is equal to C is equal to 10, then that means I am writing like A is equal to into bracket B is equal to into bracket C is equal to 10. So that first it will do C is equal to 10, then B will become 10, and then A will become 10. But I don't need to put bracket. It will assign 10 to all the 3 variables because assignment operator has got associativity from right to left. So first it evaluates the assignment operator which is on the rightmost side, that is C is equal to 10. And because C becomes 10, B also will become 10, and then A also will become 10. But another example we see where I say 72 divided by 2 divided by 3. That is treated as actually 72 divided by 2 whole divided by 3 because the division operator has got associativity from left to right. So first it will start from left hand side. So that is what associativity, which decides the direction in which same priority operators are evaluated. Please note that there is no explicit operator table in Java and different table on web disagree in some minor ways. So this associativity list is not properly defined in Java. If you refer to different books, you may find some slight difference, but no, not major difference. But from board point of view, exam point of view, you remember that assignment operator has got associativity from right to left, whereas division operator has got associativity from left to right. Even the unary operator has got associativity from right to left. So enough for today. This lecture. We'll see next lecture with a new topic. This table is given in textbook, so you can refer to this textbook and understand that which operator has got what associativity it has got. As you can see, unary operations of plus plus, minus minus, exclamation, that is logical not, unary plus, unary minus, and typecast, they all are having associativity from right to left. And the last two, that is conditional operator and assignment operators and relational operator, a shorthand assignment, sorry, it is shorthand assignment operator, they have got associativity from right to left. Otherwise, most of the operators are having associativity from left to right. Now, next is block statement. A block statement is a group of statements enclosed within a pair of curly bracket. So when we write more than one statements within set of curly bracket, it is called block of statements. The main purpose is those statements will get executed together. So as you see in the example on left hand side, the block of statements begins with opening curly bracket, ends with closing curly bracket, and then there are four statements written. Integer temperature, temperature is equal to x, x is equal to y, and y is equal to temperature. So actually exchanging the value of x and y. But this is what block of statement. All these four statements are considered as one block. So that is block of statement. Rest of the things you know, that double slash, they all are comments. So what is the use of block? So block is used for grouping sequence of statements into a unit so that they will be treated as a single statement. Again, used to group logically related statements together so that they imply that those statements, whenever executed, should be executed together. And it creates variables with local scope. So when you create a variable within a block, that variable becomes local variable. So its scope will be local. A variable declared inside a block is completely invisible and inaccessible from outside the block. Remember this. If you declare any variable inside a block, for example, as you see in this integer temp, so variable integer temp is having its visibility only within this block. Once this closing curly bracket of the block is executed, outside of this closing curly bracket, variable temp temp is not available. It is not accessible. It is invisible. So when the variable is created, it occupies memory, and when the block ends, the memory is released for reuse. Such variable is said to be local variable to that block. In this example, x and y are not local because they are not defined inside this block. Remember, only variable temp is defined here within the block, so it is local variable and its scope is only within this block. So scope of variables. The scope of variable is the part of the program in which that particular variable is available and visible and accessible. So the area of program, the statements of program where that variable is available for use, that area is called scope of that variable. The scope of a variable which is declared inside a block is limited to that block only. We already saw in this example that block, the visibility of temp variable is only up to within this block, and variable temp is not available outside this block. Let us see this program which is given in the textbook. If you see here, public static void main, class block, class is block, and then inside we have main method. Inside main method we have variable integer x is equal to 10. Now remember, this variable x is equal to 10 because it is derived or created outside any method. So x is available in BLK1 and BLK2 also. It is available in BLK1 and it is also available in BLK2. So if you observe this, in BLK2, integer x is equal to 30 written, which is error, because x is already available, so we cannot create x here. But y in BLK1 and y in BLK2 are totally different things, because y is not declared outside the block, variable y is declared inside BLK1. So its scope, its life, its accessibility, its visibility is only within this block. Once this curly bracket gets over, it is closed, variable y is also cleared. So when you create new variable here, it is a totally new variable, it has nothing to do with this y. But x cannot be created here because there is already variable x which is available in all the block 1 and block 2. So you cannot have two variables with the same name. So this will generate error, which is rectified here. And here, as you see, the variable x is removed. Otherwise program is same. But this left hand side program will generate error and right hand side program will not generate any error. So that shows the scope of variable. Control structures. In general, now this is totally new topic and almost we are at the end of the chapter, but still this topic has got so many other subtopics. So control structures. In general, program statements are executed sequentially, that is one by one. When you write a program, that program gets executed sequentially. First statement, second statement, third statement, and so on. But sometimes program logic requires to change the flow of this sequence. So sometimes program requires that you change this flow. At certain point of time in your program, you don't want to continue with the next statement, rather you want to skip some statements, or rather you want to repeat some statements again and again before going ahead. So how to do this? So for this, the statement that enables to control or to change the flow of execution of the program are considered as control structure. So rather it is very simple that those statements which changes the control of the program or the flow of the program are called control structures. There are two types of control structures, loops and branches. In Java, control structures that are used to change the normal flow of control in a program are if statement, switch statement, they both are known as branching. For statement, while statement, and do while statements, they all three are loops. So there are two types of control structures, loops and branches. For branching, we have if statement and switch statement, and for loops, we have for, while, and do while statements. Let us see all these 5 statements one by one. If statement. One of the easiest statement is if statement, because if statement is something which we know right from our childhood, because if is used in program exactly the same way as we speak in our spoken language. We say that if you read, you will pass, else you will fail. If you take umbrella, then you will not get wet during rain, else you will get wet. So if statement is something which we always use in our spoken language, and it is used in programming also the same way. So the if statement, when used, it enables to take one of two alternative courses of action depending on whether the value of a given Boolean expression is true or false. In simple language, if checks a condition. If that condition is true, it will do something, and if that condition is false, it will do something else. As you see here, this diagram or flowchart rather, here we have Boolean expression. Now you should know that what is Boolean expression. We already discussed. This Boolean expression you know that Boolean expression will result either in true or false. So if this Boolean expression results in true, control will go here and it will execute statement 1. If this Boolean expression results false, control will go this side, it will execute statements 2. But ultimately after that they will come to the next statement. So that is what if statement. Here also the same thing is shown using programming style. That if into bracket we write Boolean expression and within set of curly bracket we write statement 1, else again within set of curly bracket we write statement 2. Now let us see about these statements. There is something to understand about this statement also. So when if statement is executed, it first evaluates Boolean expression. If that Boolean expression's value is true, it will execute statement 1, and if false, then statement 2. Statement 1 and statement 2 in if statement are usually a block statement. That means block of statements, multiple, so many statements, more than one statement. It may be any single statement also. Sometimes there may be only single statement, that if condition is true, you want to do something which is written in one sentence. But it is advisable to use block. Even though there is only one statement, it is advisable to use block. And block, you know that how block is used? By putting them within curly bracket to make it easier for the programmer to insert or add new other statements afterward. So what happens is, suppose if I don't put semicolon, if I don't put these curly brackets here and I have only one statement here, I write else, again I don't put this curly bracket and write another one statement here. Program will run perfectly. But suppose in future I need to add one more statement here, and if I add that statement and if I forget to put curly bracket, then that would be error. So it is advisable that even though you have only one statement after if or after else, but better you write it them within set of curly bracket so that programmer will not face any problem afterward. Keyword else and the block after else is optional. So this part is optional. This part is optional. It may happen sometimes that when condition is true, we want to do something, but we don't want to do anything when condition is false. So you can avoid writing else and the block after else. When an if statement is used in another if statement, within another if statement, it is called nested if statement. So nested if statement is the one where if is written within another if. Next is a switch statement. A switch statement is used when there are many alternative actions to be taken depending upon the value of a variable or an expression. In simple, you want to check a condition where now there are not two possible answers but many possible answers. For example, if is used with such condition where there is only Boolean expression, where there are only two answers, true or false. But suppose there are certain situations. Suppose if I ask somebody that which standard do you study in? So the answer, there can be so many possible answers. If I ask Boolean question that are you studying, then there can be two answers, yes or no, true or false, which can be checked using if. But if we are asking such condition or such questions where there may be more than two possible answers, then what to do? So for that we can use switch statement. So once again we read the first sentence, that a switch statement is used when there are many alternative actions to be taken depending upon the value of a variable or expression. The test expression which is written with switch here, this is test expression or simple expression. So the test expression should be of type byte, short, integer or character. It cannot be of type long also. So the value of test expression is compared with case. Now whatever test expression right here, its value will be compared with all these different case one by one. as many cases you want to write, you can write. And when a match is found, the respective statements are executed. So if this expression match found here in case constant 2, then statements 2 will be executed. If it is found in case n, these statements will get executed. And if it is not found in any one of these cases, it goes to default. So that is what if switch statement. So if no match is found, then the default statement is executed. Now the break statement, everywhere if you see break, there is break. Here you see break, all will have break, here break, even after default, here also we can write break. So what is the use of break? Break statement is used to send control out of switch statement after each case, but it is not compulsory to write break. It is only used to send control out of the switch statement, but sometimes if you don't want to send out of the switch statement, you may avoid writing break. See, one more thing I want to explain here is, please pay attention to this thing, that break is why required, because if first case is matched with this expression, first case itself matched, and if I don't write break, then program will execute statement 1, it will also execute statement 2, even though second case is not matching, but still control will come. So what happens is, once control enters any of the case, it will keep on executing everything until it finds break. Remember this statement very carefully, that once expression matches with any of the case in your switch statement, then it will keep on executing every statement until it finds break or until the switch expression is over. So break is that way important. But let us see one example where break is not required to skip some break statement. So this example, suppose we are asking a student that which standard do you study in, and we limit to standard 8 only, and what we want to do is, if student is studying in standard 1, 2, 3 or 4, then we want to print pre-primary section. And if student is studying in standard 5, 6, 7 or 8, we want to print primary section. That is what we want to do. Otherwise we will print that wrong standard entered. So what we have done here is, I have not written anything in case 1, case 2, case 3. And only in case 4 I have written pre-primary. Now you will wonder that, what if student enters standard 2? Suppose, for example, student, the value of standard variable std is 2, then it will not go in 1, it will go in case 2. Since there is nothing written, even break is not written, it will keep on executing everything. So it will go to case 3 also. Nothing is written, even no break, it will go to case 4 also. There is something written, it will print pre-primary, and then there is break, so switch statement gets over. Similarly, if the value of standard is 5, it will come here, no break, goes to 6, again no break, goes to 7, again no break, goes to 8, prints primary and break. And if I enter anything other than 1 to 8, it will go to default and will print wrong standard and break. So that is how sometimes we can avoid break. So when break can be avoided, whenever you want to do same thing for many of the values, as here in our case 1, 2, 3, 4, we want to do same thing. 5, 6, 7, 8, we want to do same thing. So whenever you want to do same operation, or whenever you want to take same actions depending on the value of a variable, then you can avoid writing those statements in every case and write only in the last possible case and then write break over there. So that is what switch statement. Now next is repetitive control structures. Java supports 3 types of looping constructs, that is repetitive control structures. They are for, while and do while. Now what is the difference? All these 3, the common thing is all these 3 are used to repeat something again and again. Now what is the difference? When and in which circumstances which loop is used by programmer. So when number of iteration, that is repetition, how many times you want to repeat certain statements, so that number of iterations are predetermined. Usually for loop is used. Means if you are sure that you want to execute this number of statements for 10 times or 20 times. So when it is fixed that how many times you want to repeat that statement, those statements or block of statements, we generally use loop statement, which is for loop statement. On the other hand, while and do while loop, these two loops are generally used when the number of repetition of the loop are not fixed. That depends on certain situation. So, but again, let me tell you, this is not fixed. When number of repetitions are fixed, we use only for, and we cannot use while and do while. And when number of repetitions are not fixed, we use either while or do while only, and we cannot use for. No, it is not like that. This is in general. So when number of iterations are predetermined, usually we use for loop, and when number of repetitions are not fixed, generally we use while or do while loop. Do while loop is again now the difference between while and do while. Do while loop is used when programmer wants the loop to be executed at least one time in any situation. So when programmer wants that this loop for in any situation, for any condition in your program, but that loop should get executed at least one time, then we use do while loop. So for and while are entry controlled or pre-test loop. So for and while are entry control or pre-test loop, means the loop gets checked, condition gets checked before you enter the loop. And at the beginning itself, if the loop condition is wrong, then you will not be allowed to enter the loop. Whereas on the other hand, do while is exit controlled or post test loop. Means that entry to the loop of do while, nothing is checked. So you enter the loop without any condition to be checked, but when going for the next repetition, it checks for the condition, and if the condition is not satisfied, loop will get over. But it will get executed at least one time. That is in do while, because it is exit controlled or post test loop. Let us see in detail. Let us first see for loop. The most widely used loop construct is for. For example, if we see one example, then for has got three arguments or three parameters. 4 into bracket, if I write integer I is equal to 0, I less than 10, and then I plus plus. Now you should understand all these things. If you see, there are many different operators are used. I is equal to 0, that is assignment operator. I less than 10 is a conditional or comparison, it is comparison or relational operator, and I plus plus is a standalone increment operator. So these are the three expressions used with for loop. What it indicates is that value of I begins with 0, and every time it increases by 1, and then keeps on doing this thing till the value of I is less than 10. Once it reaches 10 or above 10, the loop gets over. And what we are doing inside the loop is we are just printing the value of I. So that is system.out.println, and we are printing the value of variable I. Here value of I is initialized to 0, as you've seen the first initializer, I is equal to 0. Then it checks the test expression I less than 10. So then it checks whether the condition is true. So I is less than 10. So yes, 0 is less than 10. If it is true, then it will execute the block of statement written within set of curly bracket. After that, so once that block of statement is executed, control again goes back to for loop, and value of I is increased by 1 using the statement I plus plus. So now I becomes 1, which was 0. Now it becomes 1. Again it checks 1 is less than 10. Yes, it comes inside the loop, prints it, again goes back, it becomes 2, checks the condition, comes inside. This will keep on doing So continue till the test expression is true. Once the test expression becomes false, the loop will terminate. So consider when I is 8, it will go up in the loop, it will increase by 1, so it will become 9. It will check 9 is less than 10, yes, it is true. So it will come inside the block of statements, it will print the value of I, again it will go back to the for loop, it will be increased by 1, so now I will become 10. It will check 10 is less than 10, no, condition is false, so loop will be terminated. So ultimately this loop prints all the numbers from 0 to 9. While and do while loops. While, as we discussed, is an entry controlled or pre-test loop. Here it is possible that statements in loop are not executed at all if the condition in the beginning itself is false. So if the test expression which we write with the while initially itself is false, then it will never execute the loop. Do while is exit control loop. On the other hand, do while is exit controlled or post test loop. Here the statements in the loop are executed at least once in any situation. So in both these loops, the test expression, that is the condition, is written along with while keyword. So for example, while test expression like while n less than 10. So that is how we write test expression with while. Both while and do while repeats the loop till the condition, that is test expression, results true. And once it results false, that loop will get over. So these are the examples. If you see the first, it shows the on left hand side, it shows the syntax of while and then example of while. And on right hand side, it shows the syntax of do while and an example of do while. So syntax is of while is while, and we write text expression, and then within curly bracket we write block of statements. For example, let's say n is equal to 0, so initially n is 0. So remember, this n is equal to 0 is not part of while statement, but because just to show you that there is a variable n and its value is 0. Now it checks whether n less than 10. Yes, 0 is less than 10, so it will execute all the statements, including a statement where value of n is modified, which is n is equal to n plus 1, or it can be n plus plus, whatever you write. I have written, intentionally I have written in both the program the same thing in different way, so that you should again remember the shorthand, as you should also remember assignment operator and increment operator. So either you write n is equal to n plus 1, or you write n plus is equal to 1, or you write n plus plus, or you write plus plus n. Everything is same. So it will be increasing value. Again it will go back to while, checks condition, and this will keep on doing until the value of n becomes greater than 9. So that is while. But if you see here, this n is equal to 0, if I make this n is equal to 11 right from here, beginning only. If I make n is equal to 11 here, you can see that it will never execute the loop, while loop, because 11 is less than 10, no, condition is false. So this loop will terminate and it will not get executed. So that is what an example of while loop. On the other hand, here on this side, let us see how do while is called exit controlled or post test loop. So as you see, it starts with do. There is no test expression here, so there is no chokidar here, nobody here to see that, control that whether control should come inside or not. It is only when you go for the second repetition there is a test expression here. For example, again same, n is equal to 0, we say do, open curly bracket, and we write statements, including a statement where we are changing the value of n, and then curly bracket over, and then we write while n less than 10 and semicolon. See, if you observe here, there is no semicolon after while. Even in for loop, here after for there is no semicolon, but In do while, after while there has to be semicolon because do while statements ends here. And Java says that every statement ends with semicolon, whereas while is not getting over here. While gets over here as at the closing curly bracket, and curly bracket doesn't require semicolon. So here it says n is equal to 0 comes inside, you executes all the statements, increases value of 1, then check n value is increased, then it checks this condition, again goes back and does thing. But here, if you see, if I make this n is equal to 11 here, or rather even if I make n is equal to 1000 here, then also these statements will get executed at least one time, because while entering the loop, do while loop, there is no condition checked, there is no test expression checked. So it will come inside, it will execute all these statements. If it is 1000, it will become 1001, and then it will check 1001 is less than 10. No, condition is false, and it will go out of the do while loop. So that is why do while loop is a special loop. It is very useful for programmers in a situation when programmer wants to execute the statements at least one time in any situation. Anything happens, but programmer wants to execute that statements of loop at least for one time. That time do while loop is the only option. Break and continue statements. Break we already discussed with switch statement, and there is another statement called continue statement. The break statement, when it is used, it is to transfer the control outside switch or loop structure. So if you want to abnormally exit the loop, then you can use break. For in certain situations, suppose you are dividing two numbers, you are asking user to enter two numbers, and then you are giving the output of division of those two numbers, and you want to give user this kind of option for dividing two numbers for 20 times, so user can do the calculation for 20 times. But suppose in between user enters second number as 0, and you know that any number cannot be divided by 0, and if it is done it will create or generate error. So in such situation you want to break a loop, that when user enters second number as 0, then you want to break the loop and you don't want to continue. So break statement is used in such a way. So when break is used in switch structure, it skips all the following statements and control is transferred at the first statement after the end of switch statement. In a loop, break is used to exit the loop. It can be for loop, while loop, or do while loop. On the other end, the continue statement is used to skip the following statements in a loop and to continue with the next iteration, that is next repetition. So continue will not break the loop. Continue will only skip one repetition, the current repetition, and it will start with the next repetition again. So that is the basic difference between break and continue. As such, you should understand it, because the use of break and continue is same as the word meaning of the break and continue. As the break says, it will break the loop, whereas the word continue means it will only skip current repetition and then it will continue with the next repetition. Nested loop, there is another topic called nested loop. Very simple topic. When we write a loop inside a loop, another loop is called nested loop. You may write for loop and then inside for loop you write do while loop, or you may write for loop within another for loop, any combination of loop. But when there are two loops written together inside one another, it is called nested loop. So loops of same or different types can be nested in Java. As I said, within for loop you can write do while loop or while loop or even for loop itself. But that is called nesting of loops. The last topic of chapter 7, and that is labeled loops and labeled break. What is label loop and label break? First, let us understand. See, when we write nested loop, when we create nested loop, suppose there is a loop 1, inside that there is a loop 2. Now in loop 2, if I write break statement, it will break only the loop 2. Loop 1 will continue. Now when loop 1 is continue, and because loop 2 is written within loop 1, so loop 2 also will continue. It will not break. So what to do at this time when you want to break multiple loops? So for that, here it is the solution, and that is by writing labeled loop and labeled break. So while using nested loop, break statement breaks only the nearest loop. So for example, here if you see for loop, within for loop we have while loop, and within while loop we have written break. Just forget there is written out is written here, out is written here. Just now you just avoid that. Now if this break is written, only break is written here, it will break only this while loop. But this for loop will continue, and because this for loop is continuing, this while loop also will continue executing. So what to do? So what we can do is to control which loop to break and which to continue or iterate, we can use labeled loop. And how to create labeled loop? So to use labeled loop, add a label followed by a colon sign before the loop, as it is done here. Label, you write any label, whatever name you want to write here, but it should be a single word. So here I have written out and colon. Now what happens? Then add this label after the keyword break or continue to transfer controls elsewhere other than enclosing loop. So here we have said break out. So break out means it will break the loop where the name of loop is out. So ultimately it will break this for loop, and because this for loop is broken, this while loop also gets break. So that is how we can use labeled loop and labeled break. Is a very advanced topic. It is only required when you are writing a complex program. As a student, so you may write a program where there are only one loop. You don't even need nested loop. It is only when you are doing some graphical programming or some program where you have to work with tabular data, you need nested loop. And when you are using nested loop, the question comes of how to break the entire loop structure. So that is by using labeled loop and labeled break. So that's it for chapter 7 till now. Take care and stay safe.